Hello, everyone, and welcome to the EBA webinar series. I am so pleased to welcome Doug Tarry today. Doug is going to be presenting on From Bleeding Edge to Leading Edge, a builder's guide to net zero homes. And this is probably, it's been some months in the making, and the book is soon to be coming out. Doug will also be speaking at the EBA Summit, September 15th, I believe. No, 16th. You're closing out on the 16th. The final keynote along with Gene Myers, and we really look forward to that. But I will tell you, if you are a builder out there and you are looking at how to build net zero, Doug has been on the journey. And I think it takes it from that, probably the pathway that you went down, Doug, to those of us that are following behind you into a super highway of being able to accomplish this. And as we've read about the climate and the impacts and things that are going on, it's of paramount importance that all builders are taking a look at this. So this is part one of a 4-part series. We do have AIA credit for this course, and this is changing our paradigm, the 4 principles of modern design. So next slide. So that's obviously me, but we're really proud to represent EBA. Doug Tarry's been part of EBA, part of the Builder Benchmark Group, but we have a community between EBA and Team Zero and our other collaboration partners of over 50,000 builders and their stakeholders across North America. And I think the really fun thing is that if you go back 39 years when EBA was started, it was builders from Canada, from the United States, and from Europe that really launched EBA to being more energy efficient builders. And throughout the past 39 years, we've really advanced to net zero, looking at zero carbon, looking at zero health impacts across that. So if you are interested, I really believe that EBA are the early adopters and innovators like Doug Tarry Homes that are driving sustainable transformation in the home building industry. So Doug, welcome. And I think we're going to kick it off with a survey.
Yes, sir. Thanks, Aaron. Just wanted to get to know the audience just a little bit more, and I'm hoping that you and Nancy are going to be able to help me out with this. But what is your occupation? Are you a builder, an architect designer, energy rater, a trade contractor, manufacturer, or sales? Are you in government, or are you falling into the other category?
You should see the poll on your screen and you should be able to click in.
I can see the different options here. Now there is a different survey question as well. I'm assuming we'll do that after.
Yeah.
Okay.
And if you are unable to do the poll, maybe you just chat your occupation to us.
It says I can't vote. I would fall into a couple of those, but that's okay.
Me too.
They didn't have CTO, which is I consider that to be my new title at Doug Tarry Homes, CTO, Chief Trouble Officer.
Well, I'm going to end it, but I've got one person that says technical sales in the chat.
So
we'll end that poll.
Okay. All right. So I'm just going to get going. There we are. So builders and others seems to be who is with us today. Okay, excellent. So I'm going to get into it, and I am always fond of saying it's a little bit like NASCAR. We put our foot on the gas and we go real fast. But Aaron, we talked before. Feel free to throw questions out there. I'm happy to chat as we go.
Great. Just for folks, we have a Q&A section at the bottom of your screen. Just enter any questions that you have there, and I'll present those to Doug as they come up.
Excellent. So I am president of Doug Tarry Homes, and I'm also a past president of the Ontario Home Builders Association. I am the OHBA technical chair, or at least for a few more months. I'm also a member of the Canadian Home Builders Association, Net Zero Council, and Research Councils. 2019 CHBA Member of the Year, and 2019 Enter Quality Hall of Fame inductee. I'm also a guy that likes to go and do stuff outside my comfort zone. So back in 2011, I led a team of about 190 people down to Dominican Republic, and we blitz built 6 homes in 4.5 days as a humanitarian mission down there, which was a ton of fun. And we actually had our ambassador for the Dominican come and join us, and he was supposed to come to do a meet and greet, handshake, photo op, and he stayed for 4 days, put his family in the hotel, and came to the job site and worked with us. So that was pretty cool. Also, a little bit of a snapshot about my company here then. We are a second generation home builder. We were established by my dad in 1954. I did not name my company and I did not name myself. My dad did both of those. My mom was kind of mad at him. She didn't talk to him for about 3 weeks because I was supposed to be Sean, not Doug. But anyway, our company was the winner of the CHBA inaugural Net Zero Home Award. And we are 3 times, three-peat Natural Resources Canada Energy Star Builder of the Year. We are also the very first builder in Canada to have built and labeled 200 plus net zero ready homes through the CHBA net zero program. So we've done this a little bit. Folks have asked me, you're already really busy. Why would you write a book on net zero? And for me, I would say number one of which is I've done complicated. And what I found when I've done complicated is I've realized that it's just that, it's complicated. And a lot of times people get into looking at net zero and they get scared because they think, oh my God, it's so complicated. So I thought, well, this might be a good way to be able to teach people about, hey, this is really not that much of a problem. So this is really, the book is a philosophy book. It's really more about the why and how as opposed to the what. There's some really great books out there on what, and we're not trying to duplicate that. It's the book I wish I'd had when I'd started. And when I took on this guide, it was actually originally Natural Resources Canada that came to me and asked me to write this for builders in Canada. This is here to help builders prepare for what we're going to have to do as an industry and as a society. And that's really regardless of your beliefs about climate change, no matter which end of the spectrum you land on. I'm conservative in the sense that I believe in conserve. And so we have an opportunity here to demystify, if you will, and that's what the goal is. So about the guide and the webinar, like I said, it is a philosophy book on the why and the how. I write it as a series of short stories to make it interesting so you can follow along and kind of get the gist of it without getting into a real technical journal, but there's some really great takeaways in it as well. We use details included in the book to complete the story. What the guide is not, it is not a technical document. It's meant to be an easy read and one that you find it's enjoyable to read because you remember the anecdotes and the stories. We're not trying to, as I said, repeat anything that's already been done. The desired outcome for this is to help you as builders and industry people to build and sell net zero homes in a cost-effective, market-priced, and profitable manner that creates superior value for your customers. So that's kind of our mission. We believe that your buyer is a 30 to 60-year-old woman with 1 to 2 kids. She's the decision maker, although because of eroding affordability, we are seeing extended families staying in homes now. And so there's some technical challenges that we've got to look at with that to respect the fact that there's more people in the homes than before in these high performance homes. But when we look at it, we have to think about beauty and aesthetics as well as performance. As I like to say, do you think that this lady that's your target audience wants to live in a home like this? I would suggest that no, she doesn't. So let's try and make it look nice too. Best reason ever for me to want to do this, that's my grandbaby Corbin. They call him Mini Me because he looks a whole lot like me. Unfortunately for him, I guess. But here he is.
He's got a great hairstyle, huh, Doug?
He does. He's got the punk rock look all figured out. I used to do that, but I lost my top. So yeah. He's a great kid though, lots of fun. So the agenda and the objectives for today, this is, as I said, it's about demystifying net zero, making it accessible to people. It's about changing our thinking about net zero. It's looking at cost, it is value proposition versus simple cost. We want to move the industry forward from bleeding edge to leading edge. So part of that is getting more people to adapt the low-hanging fruit, if you will. We're also looking to create broad market appeal and acceptance of it. We want this net zero product to be the preferred brand in the marketplace. So getting started, the Coles notes, if you take nothing away from these sessions, there's 4 steps I think you need to consider. The very first one and number 1 and number 2 are what I consider the 2 fundamentals of building that thou shalt get figured out, and do that before you do pretty much anything else. Now, because of the structure of the sessions, we're actually going to cover 1 and 2 in the next session. But the first one is, what is your water management strategy? And I just see so many mistakes on this throughout the industry that it's really critical. And dealing with the insurance industry, water damage is the largest risk, whether it be from flooding, whether it be from rain, from storms, what have you. It is number 1. Unless maybe you're in California or BC, that sort of thing, where you've got all these fires happening. But water right now is considered the number 1 risk. Number 2 is have a clear understanding of your plan for air tightness. Between air and water penetrations, they kill high performance walls. And if we want to advance building science into the net zero area, we've got to get these 2 fundamentals figured out before we really go on to anything else. Because if we don't, we're not going to have success that we need to have. Unfortunately, we tend to fixate more on insulation, which is number 3. Now we can add insulation. We tend to fixate on that before we've really mastered the fundamentals of 1 and 2. So my suggestion is, let's go and look at those first and make sure we've got great plans for that. And then we can talk about insulation, and then we can start looking at the bells and whistles. And when I do say bells and whistles, keep it simple. Don't put a spaceship in the basement. Customers don't like it. They don't understand how to use it. Okay, so changing our paradigm. Back in 2017, we were really blessed with an opportunity to help a family out. They'd lost their husband and father to cancer the year before, and they had an issue with their life insurance. So they were really in pretty bad shape finance-wise. And so what we decided, you see, is because it was crazy, is to build a net zero ready home in 3 days. And then we sold the home and gave the proceeds to the family, the profit to the family. So how did we make that happen? Well, the first thing I realized is I couldn't let the construction team touch the schedule. And the reason for that is because they knew 1,000 reasons why a 3-day schedule wouldn't work. But what we needed was one person that didn't realize it couldn't work, and that was Carrie O'Brien. So she was a planner in my office. She was a junior planner. And I went to her and I said, I want you to take this on. And it took us 9 months to plan it. But at 39 hours of the build, we did a blower door test, and it was 0.63 air changes, one of the tightest homes I've ever built. And in fact, it was the only home I believe that I've ever built that did not get wetted because we closed it in so quickly. We had over 600 volunteers on that project, and the actual documentary short film is now at the film festival circuit this year. So it took a while to do it, and we're pretty excited to see that happen. But there is a link at the bottom if folks are interested in seeing the teaser or the trailer. But a great project. And the biggest thing we learned about doing a home that fast is the number 1 thing that happens on the job site. Aaron, do you know what that is? The number 1 thing that happens on a job site?
No.
Nothing. So if you remove all of nothing, you can kind of speed up your job site a fair bit. And that's part of what Carrie had to do, is she got rid of all of the nothing first and then figured out how to compile it from there. The point is it's about changing our paradigm. We perceive ourselves as having an understanding of this is what we have to do. And when we start to move from code built homes to net zero homes to beyond net zero homes, it really comes down to, okay, well, how can we maybe do this differently? What can we rethink that might work better or in a different manner? And my philosophy that I talk about in the book, and I'm going to speak about here today, is around kick, okay? And I believe that we spend so much time fixating on insulation and mechanicals and performance values that we've really lost sight of where the direction really should be, in my mind. And so that is to design and construct our homes to what I call kick, which is design for occupant comfort, ensure that we've got great indoor air quality, look beyond energy reduction and look at your total carbon footprint. And I don't mean operational carbon alone, I mean operational and embedded carbon. And then we have to construct climate resilient buildings. So up here in Ontario, Canada is actually the 2nd leading country in the world for tornadoes after the United States. And we just had a pretty bad one up in Barrie, Ontario a couple of weeks ago. And those homes, if they'd been constructed to the methodologies that we use, they would have survived. So it's important. When we look at carbon reduction, that's kind of an insurance policy. When we look at climate resiliency, that's acknowledging that the horse is out of the barn and the barn's burning down. So we have to kind of balance both. So what is net zero and why should we care? So this is assuming you know nothing about net zero. In simple terms, a net zero home creates as much energy as it uses over the course of the year. Why should we care? Well, frankly, we've only got one planet. Earth is our one and only home. Our shared role should be in ensuring that it's safe and livable for our children's children. So my grandbaby and beyond. And I'm a huge fan of Joe Strummer. I would have to say he had one time said in a song, hey, I hear what you're saying. If you're going after getting the honey, then don't go killing all the bees. And that's what we've got to try and avoid doing. We have to make sure that we're thinking long-term on this. So in building our team for coming to net zero and what we're needing to do, you really got three core teams you need to look at. You've got your consultation team, and there you need an experienced energy advisor to lead you down the path and make sure that you're going in the right direction. You need to supplement that with a solar consultant, an HVAC designer, an installer, your window supplier, your building official, and your utility guy to make sure that you're able to cover this off. The next team is your construction team, and you've got to engage your site supers early and frequently, as often as you can. They have to know what's expected performance-wise in the field, and they have to be able to troubleshoot. So it's really important that they understand what the goals of the program are. You also need to look at any trade that touches the envelope. They have to be included because they can wreck your day in a real hurry if they don't know. And the last group is the folks that we rely on, the seller team, the sales and marketing team. And because they have to sell it, they need to understand it. They need to be on board with it. So getting their input and buy-in is really crucial. Don't leave them out, even if they're on commission. You got to make sure that they're on board with this so that they feel comfortable and can relay the importance of this to your consumers, right? Because if you're not careful with this, they could really fight against you on it because they're worried. Their livelihood is based on those sales commissions. And if they think that's going to be taken away from them, you could have some serious pushback from them. So much better to engage with them and get them on board. So the first big concept is to talk about total value contribution. I mean, I hear about talking about cost all the time, and there's some real errors that can be made when we only look at a base cost of an item as opposed to looking at the value contribution. So let me see if I can't straighten this out a little bit for folks. The first one is there is always someone who's going to charge less. On the left, of course, is the Mona Lisa, and on the right is a grade 3 version of it. One is not the same as the other. I've had the privilege of actually going and seeing the Mona Lisa many years ago in Paris in the Louvre, and it's quite something to see. Very, very different the way her eyes follow you. It's kind of cool, but you can get something cheaper than that, and that's where we have to look at: is it better to be cheaper, or is it better to look at value? So I look at, before we select our specifications, we have to consider that our world is changing, and so are our customers' expectations, right? Energy programs, like I said, they primarily focus on reducing energy. That's why they're an energy program. They have limited focus on other considerations for a dwelling that's going to last 100 plus years. So often folks will say, well, it's good enough. Why can't I just meet the requirements of the program? Isn't that enough? And I say you could, but there's cost-effective opportunities there that you'd be missing if you don't take a holistic approach. So we recommend looking at it from that perspective. So we want to consider the long-term impact. We need to look at, as I said, occupant comfort, indoor air quality, climate change, and carbon reduction. Our customers expect all of this actually without us even talking about it with them. They just assume that it's being done. They don't know any better. And part of the reason for that is because you look at buying a car, and I don't know, I can't remember how many years it's been since I changed the oil on a car. It's been a very long time. I guess I probably could if I absolutely had to, but I'd make a real hash of it, so I don't do that. But that's the way cars are nowadays. They're more complicated, and people are afraid of them, and we have to demystify that. So meeting the program requirements without looking at kick, it may not meet the client expectations is the concern to see, and you could leave yourself exposed to a warranty issue. However, I've seen it again and again. If the customer has to pay extra for something, and it's not something that they think that they need at the beginning, they're going to say, if it's so important, then why isn't it standard? And so what I found over the years is that when we look at going up to Energy Star, it was more successful once we just set it standard. When we looked at sub-slab insulation, it was more successful once we made it standard. When we looked at low solar glass, same thing, right? And Net Zero was no different. We finally got enough traction on it that it was time to pull the trigger, and then the problems went away. So I like to look at total value contribution. So I find that too often decisions about specifications are made strictly on cost, and cost versus total contribution is what I like to consider instead. And I'm going to look at windows and specifically on U value. So here in Canada, we've got a program through the Energy Star program for windows, and it prefers what's called energy rating. And God bless America, you don't have energy rating in the States. But I like to look at U value, and having a low U value is for me much better. So we focus on U value, even though the windows I use actually don't qualify as an Energy Star rated window here where I'm building. But we select a triple glazed window that meets the code requirements or the program requirements, whether or not it's an Energy Star one, because we can't gain heat. And so we have to look at that. So we put together a little comparable here. And if we were to just look at window with low U value, and I'm looking at my comfort, indoor air quality, carbon, climate, and I do add energy as one of the matrix mixes, just for a reference point for people to understand that it does still involve around energy. In this case, we can check or part check some of the boxes. So indoor air quality is improved with the triple glazed window. There's less chance of mold in the winter time. Comfort is improved. We've got less radiant energy loss. So at the window, you don't feel cold drafts sitting beside it. So it's somewhat more comfortable as well. And it's a little bit of an improvement on the energy piece as well, but it doesn't address summertime heat gain. So when we're looking at windows, we want to talk about low solar heat gain coefficient, right? And my recommendation to any builder, pretty much anywhere that has sun, is get it under 0.3. Now, solar heat gain coefficient should be very available in the States. In Canada, it took us quite a while to get that, but it's very much so worth looking at. And I've met with builders in the States as well that don't consider this, and they're going for, the best wall that they can build as opposed to the best wall system that they can build. And the windows are an important part of that. And we'll get into that in one of the future sessions. The challenge with not dealing with low solar glass is that you're going to blow up your energy loads on the cooling side. And so if we're able to add low solar glass, it's going to reduce our AC sizing, which makes your ducts smaller. And that's really important, especially if you're still doing that stuff about putting them up in the attic. If your HVAC contractor doesn't understand about the relationship with low solar glass and being able to put in smaller systems, then the first thing you do is you retrain your HVAC contractor. And then if that doesn't work, then find a different HVAC contractor. It's that important. People will say, well, why would I spend more money on the windows? And here's the thing. Let's say a $10,000 window package, fairly small home, costs you an extra $1,000 to go low solar glass. So it's going to add about 10 cents more per dollar, or 10% more. Will a customer pay $1,000 more on a $500,000 home? Well, they probably would if you explain it to them. But if you build it into the total value contribution of the home and it's not included as an extra, then it's an after the fact, I just got this really great deal and oh my goodness, my home is really comfortable, which is kind of the goal. So now we look at a comparison of going from regular glass that's triples to adding a little solar glass. And now we've got greater comfort both seasons. We've improved the indoor air quality year round because you get rid of that heat stuffiness that can happen in the summertime, right? We've improved our climate resiliency, and we've improved our carbon reduction because we're really now hammering away at reducing the heat gain that we can't control in the summertime, the intermittent load that's hitting right at the time that peak loading for your electrical grid is happening. And then energy is, of course, reduced as well, so energy consumption. So we're able to do a lot of things for $1,000 more. So that's why, in my mind, that's a better overall value contribution than just looking at less expensive glass, right? What it doesn't factor in though, is that you're also going to save money on your air conditioning and your duct sizing, because your air conditioner can drop in size and your ducts get smaller. So you're using less materials. That's also another way of reducing your carbon footprint on this as well. So it's a win all the way around. And then your customers really enjoy it. And the best way I've found for demonstrating this is get a nice sunny afternoon with the window glass right there, and take the customer and have them put their hand right on the glass and say, "Isn't that cool that your glass is cool?" And they're just floored by that. And of course, they want to tell all their friends about it as well. So the first
Hey,
couple
Doug,
of pieces.
Doug, quick question on that one.
Yeah.
Do you omit the low solar heat gain coefficient glass on the north side of the homes, since they may or may not be impacted, or do you do it across the whole package?
I'm not that mean to my framers. I do it across the boards above grade, because we used to do spectrally selected glass. And the problem with that, Aaron, is then you got to try and figure out, okay, which window is this 4x4 window? Which wall is it supposed to go in?
Got it.
Right. And it just makes it really difficult. Now, where I am, I'm around 41.5, 42 on the latitude, right? When we're in July, August, the sun's actually a little bit north of us for a while.
Sure.
So there's still a benefit on putting it on the north side as well. And then Gord Cook would tell you as well, it actually helps to reduce radiant loss outward as well. So it helps to keep the energy within the home. So
yeah, great point.
There's benefits all the way around. The only spot where we don't do it is when we've got an exposed basement, where we think, okay, well, we might gain a little bit of heat warming into the basement, but I can see at some point down the road that we'll just say to heck with it and do it on those windows as well.
Great.
It's just less available right now for certain basement windows, but above grade, I would not try and separate it out.
Yeah. Perfect. Thank you.
Yeah, the difference in cost, it's not worth it.
Great.
All right, so here we're going to look at comfort and indoor air quality. And one thing I always like to talk about is the trouble with comfort is getting people to understand, when would you like to have fresh air? But those two concepts, they're similar, they overlap a lot, and sometimes solving a comfort issue can often resolve an indoor air quality issue, and vice versa. And again, we want to try and see that we're hitting total value contribution benefits. But I like to talk about Goldilocks. Now, Aaron, I don't mean it in the sense, I think she was on to something, but I don't mean the fact that she was a break-in and enter hooligan that, had no regard for other people's property. Because when you think about it, I mean, really, Goldilocks wasn't really a very nice person. And you kind of got to feel a little bit bad for Baby Bear, right? He had his home invaded, his breakfast eaten, his chair destroyed, and he found someone in his bed who then ran away on him right when he was wanting to play with her, right? So he thought, well, the one good thing I'm going to get out of this is at least I got somebody to play with, and she runs away. So clearly she had some serious entitlement issues. That's not what I'm talking about here today, but it's a pretty great story. Right? What I'm talking about is the just right principle, or the middle path in decision making, which is actually known as the Goldilocks principle because of this. And so how do we as builders ever attempt to handle the question of occupant comfort when it's such a subjective feel to the occupant, right? And the answer is make Goldilocks happy. You want to hit for the middle, right? So that's what we want to try and do. As far as comfort, in my personal experience, and part of the point of the guide is to share my horror stories and everything I've screwed up. I think I probably made almost every mistake possible on comfort. I do understand that clients' expectations rise with high performance homes. They expect more, right? It can kind of feel like a forlorn hope, where you feel like you're constantly chasing. You can't get the perfection, and you don't really even understand what perfection is. And I often say if failure was a great teacher, then I've got to be reaching Zen master level, because like I said, I've been there. I've done multiple t-shirts. Most of them don't fit anymore. But I've got a pretty clear understanding now of where we need to go. And there is some hope, though, for understanding how to manage comfort better. One is the Ashrae 55 standard. And if you ever want to know more about looking into that stuff, there's a great guy named Robert Bean. He's a fellow Canadian, but he's the guru of Ashrae 55. And just look for anything that's involving with Robert Bean. He's just excellent to listen to. The other one is there is actually from Berkeley a comfort calculator. And we've used this when we've had to troubleshoot with a client's house that isn't working to see where it lands, because it'll give you a range of what's an acceptable norm based on how the occupant lives in the home, how they dress, etc. So those are a couple of background or notes that I would suggest folks look into if they want to improve occupant comfort. So, like I said, there is a health and comfort overlap, and really there's 4 key strategies here we need to look at. There's uniform heating during the heating season, uniform cooling during the cooling season, ventilation, and yes, dilution is a solution, and especially the use of a fresh air machine. Now, Sam Rashkin and Gord Cook, they both told me the same thing, so I don't know if they separately came up with the same concept of using the name fresh air machine, but I've heard it from both of them. And then the next one is a dedicated humidity control, and really 35 to 55% is the range we want it to be in. A little bit lower in the winter, a little bit higher in the summer. And we're getting to the point with these high performance homes that are super airtight that perhaps it's time to really consider decoupling that from everything else and having a whole home dehumidification strategy. In some cases, you might need to add humidity. For my perspective, most of the times we're looking at dehumidification. Having controlled fresh air into the home, though, is not only healthier, it helps you to have greater comfort. That stuffy, overheated room in summer, it's not just uncomfortable. It's also a condition that allows bad microbes to thrive. Now, when I talk about those 4 strategies, there are some folks that are going to say radon should be a separate point, and we are going to cover radon in the 3rd part of this series. But really, radon to me is an indoor air quality health issue. So yes, it does need to be addressed, but I'm saying that this is really the core for comfort and indoor air quality. Okay, so what is low-hanging fruit? Well, number 1 is rooms with a draft or a drag. We know that they're not comfortable to be in, especially in the wintertime. Rooms that have excess heat gain, that overheat and are not comfortable to be in. So, you've bought your house on the lake and you've got this great bank of windows facing the lake and it's facing west, and you can't be in those rooms because you're blown away by the amount of heat. That's probably not really prudent for comfort, right? That cold basement floor, it's amazing because a lot of folks say, well, you've got to go with in-floor heating to fix that. And, really, about an R10 of foam underneath that floor and allowing the concrete to be thermal mass within the home will take you about 95% of the way there. And I've constantly got customers saying to us, wow, I can't believe how comfortable my basement is. And it doesn't have in-floor heating, which is the Cadillac. I've got it in my own home, but we don't build with that as a standard. The other thing is thermostat location actually becomes extremely important. We really want to avoid letting the decor consultant put their hands on it whatsoever. So, if it's got to be in a certain spot to really make sure that the home works well, don't let them move it so they can put a picture there sometime in the future. It's not really fair to the customer in the long run. So we want to control air leakage, especially where people sit. We can look at zoning as an option, but I've found that if you start with looking at low solar heat gain windows, zoning becomes less of an issue because you have less of a challenge with that. But that also assumes that you're looking at mechanical systems that are modulating, right? Single stage systems. When I actually got ECM motors put into the Ontario building code for mechanical systems, I neglected to clarify that it should be modulating. So then they brought in single stage ECM motors, or direct current, you could say, which doesn't really help with what we're trying to do, which is reduce stratification by having blended air on a continuous basis. We also know that a well-insulated basement, properly designed, with low air leakage, insulation under the floor, can really be one of the most comfortable rooms in the house. So the stigma of the cold, stinky basement doesn't have to be that way. So the thermostat location, I'm chagrined, as it were, to say that this is actually from my own house. And over here on the picture on the left-hand side of the door, that's where my thermostat is. Now, the challenge with that is that when they did this design and install, there's a heated tile floor directly beneath that. So in the wintertime, that thermostat's satisfied almost all day long. In the extremities of the house, it makes it a lot more difficult. So in order to resolve that, we've actually had to turn down our tiled floored heating in order for the rest of the home to be balanced. So that's a consequence of not having it where the clock was, right? It would have been a lot easier to just put it where the clock was, and we'd have had better comfort. If you have this as a situation, as I've just alluded to, balancing the home's temperature can be extremely difficult to achieve. And that's where you start to get into the stratification. And stratification doesn't have to happen necessarily top to bottom within the home. It can happen outside the center as well, where the center of the home is nice and toasty, but the extremities just don't get enough air on a regularized basis, and they tend to be cooler or less comfortable. Or if there's excess windows, it can be hotter as well. So as I say, don't let the decor consultant dictate where the thermostat goes. Right sizing of mechanical systems is incredibly important. Right sizing actually matters. You cannot, I remember, I've gone back in this long enough now, where the mechanical contractor, he'd be going to size up the furnace system for the home or the air conditioner, and he put his finger on the thumb and get it wet, or his tongue on the thumb, and he'd stand out in front of him and he'd back up until he'd lined up the house. Oh, well, that's 2.5 tons, that size right there. And that's how they would size furnaces. I'm not even kidding. I wish I was. And unfortunately, when you do that, you're going to oversize the systems. And even following proper sizing procedures, if you follow it exactly, you have to understand that if you size it exactly according to the procedures, there is an overshoot built in. So there's a fudge factor already built in. So if you oversize above what's there, then you're getting far, far too big. But you know what happens there when you put an oversized AC or a furnace into your home? That's when you get into that I'm hot, I'm cold dance, right? I'm hot, I'm cold, I'm hot, I'm cold, because the temperature stratification is happening, because you get into an oscillation cycle. The temperature is going up, it's going down, it's going up, it's going down. And so we had that with one home that we were doing years ago, and we couldn't figure it out, that we couldn't make the home comfortable. And what happened is we found out that the furnace that was in the house was about 2.5 times oversized for what it should have been. So we couldn't get the home to balance. The temperature at the thermostat was satisfied long before the extremities were heated. And so ultimately what we found is the only way to resolve that is by right sizing the mechanical system. And then modulation in a high performance home becomes really critical, because that helps to balance the temperature throughout the home, because it can run longer. It's kind of like taking the car on the highway. You know, you let it run on long continuous run times and you get pretty good mileage. Well, it's the same with a furnace, furnace or an air conditioner. And when you get into city stop and go traffic, it's up and down or stop and start. You're not getting good mileage, but you're not getting good comfort either. So we want to have long, continuous, slow oscillations, right? And that helps get rid of the I'm hot, I'm cold dance. So supply air distribution. Supply side duct design installations. Here's a couple of examples here. Oversized ducts were that way because they were designed for the air conditioning load. So it then needs a larger fan and ducts than for the heating season. And then this is going to result in extra drafting. Now you can help to resolve this a long way just by simply, again, I said, looking at low solar glass for your windows. The other one is location of supply grills. So try and avoid locating the supply grills so they're blowing air over top of people's head. And I'm really a fan of interior wall high throw, and we'll get into that a little bit later in the next session, as opposed to floor installed systems, or specifically ceiling installed systems if you're in the south, because those just don't blend the air as well as when you have an interior wall, high wall throw across the room. What we've seen from our studies is that really blends out the air much better. Heating or cooling season, it doesn't matter, it just works better. So we want to also consider how the room is going to be used when we plan our grill locations. Try and avoid blowing air across their heads, or where people's legs are going to be bare sitting on a couch, that sort of thing. So the room over the garage. This is where a holistic approach really kind of pays off. You find that it can be too hot in the summer. It's going to be too cold in the winter. Part of how we have to deal with that is we have to reduce the duct leakage and the room leakage. You want to improve the insulation, especially underneath the floor. Again, I'm beating a drum here with the low solar gain windows. And then you want to also confirm that the airflow meets the HVAC design. So this is taking a tepid step into system commissioning, which is, I believe, ultimately where our industry needs to go. Now, we do periodic spot testing to see that our systems are working, but we are bringing somebody on staff that's going to be doing more ongoing commissioning, in part because in the last few weeks, we just started our own mechanical company. So we're taking that in-house. But you know what? Good duct design specific to the room's load with better windows, very low air leakage. And then, as I say, insulate the snot out of the floor, and you've got a fighting chance of having a comfortable room above the garage. So overall, in all rooms, really, remove drafts, knock off the heat gain, make sure you've actually got the airflow you're supposed to, and then make the toes warm, and you're done. You've got a really good assembly there. Okay, we are up on a couple of questions here, Aaron. So what do you think? Do you want to have at these? The first one for the folks here is, do you think your home is comfortable? And are we doing both questions at the same time?
Yeah, I think you'll just answer question 2 and
okay.
It looks like some people pre-answered it, so this is great.
There we go. Okay.
Yeah, I'm not sure why the questions all showed up at once, but it looks like people have answered them.
Okay, great.
Cool.
So do you think your own home is comfortable? Yes.
Yeah, okay.
And depends on the time of year.
Depends on the time of year. Yeah.
So about 33% said depends on the time of year. And
okay, that's pretty good. That's about what we've seen in other times we've done this program, is that folks have kind of a mixed feeling about how their home is. They might think it's really great in the summer, but then not so great in the winter, right? So the other question then is, do you have rooms in your home that are too hot or too cold or uncomfortable?
Yeah, that was 100% yes, Doug.
So, and this is why it's always funny to lead with the first question first, is because we ask if your home's comfortable, and then we ask if there's specific rooms that are not comfortable. And it's almost always 90 to 100% yes, that they've got rooms. So we've got some work to do as an industry, don't you think?
I would say.
Yeah. All right. So moving on, return air ducting. It's also extremely important. And basically, I like to think of this is with your return air. When you have a glass of water, right? This is an analogy I like to use for teaching clients. You can only put so much water in the glass, and then it's got no place else to go, and it starts to spill out. And so I try and teach the customers that a room's kind of similar to that. So that room over the garage, if you've screwed up on your return air and you're trying to pump warm air in there in the wintertime, it's only going to take so much in, because then it just doesn't have the ability to recirculate the air back out. So what we tend to do is we want to make sure that that return air is working really well, and then we follow those other principles that I discussed. Typically, it's going to come down to one of two things. Somebody's put in an unpanned return air using a joist, and then decided that they've not properly connected it, or somebody's added a J channel for resiliency, so you get smoother drywall. Or the other one is somebody's decided that they're going to block the return air during construction to keep the dirt and debris out of it, and then forgot to take the insulation back out. We've had that happen a couple of times, and it's just so embarrassing when you're going into the client's house later on and you're ripping a wall apart or taking the grill assembly apart or what have you to get at that insulation there. And it's like, well, we were just trying to solve a problem for you. You look like you're kind of simple. You know what I'm saying? So this is again back to being able to do duct testing. Now, there's this product called a duct blaster, and you can use that for doing some testing, or even a bolometer, which is they're fairly cheap and inexpensive now, but you can use it to measure airflow and see if you've got a blockage. And we've done that a number of times to resolve problems. Always better to do that before the client's in the home, though. But that's if you've got a problem with the comfort in a home and you think you followed everything else, that's where I usually go with my first go-to move is check the return air. And a lot of times that's what it is, right? So how do you check performance? Well, we start with a visual inspection. Ultimately, I think we're going to go to full commissioning. It's a lot less costly to do that up front than doing a warranty repair, and especially with the client looking over your shoulder. Now, I'm not talking about air conditioning today, but I might be the only builder around that's actually fixed an air conditioner for a client on a summer long weekend when there was no air conditioning guys available. And I had the dad, and it was an Italian family. The dad was standing beside me, and it's about 35 degrees Celsius. So what's that, about 85 in the home? And it was 100% humidity, and the mom's sitting behind me. And so the dad's beside me, my mom's behind me, and then And then the daughter standing, glaring at me, watching. They're all watching what I'm doing. And I said, this might be easier because it's my first time if you just let me do this without you watching. No, we're really interested in what you're doing, they said. Well, I got it done, but it was ugly and it was painful. So, commissioning and making sure things are working properly is, it's a lot less painful than as a builder having to try and figure something out on the fly.
So Doug, are you always doing duct blaster testing?
No, we do random, but
Okay.
as I mentioned, we are looking. We just in the last 4 weeks started our own HVAC company, basically out of necessity. So we're looking at doing an extended 5-year warranty over the next little while, and part of that is to get in and check the filters annual basis, check the humidity levels. But part of it as well is going to be commissioning the systems. We're moving to full commissioning probably within a year.
Great.
Yeah, it's an added expense, but you know what? It's a nice insurance policy, right? It's really not that much more money compared to having to go in and rip it out with the client. They're being very upset because things aren't working.
Right.
What I do find that's most interesting about this list of different problems that I've gone through, though, is that none of the changes that I described were a direct result of following any energy program requirement that I've ever been involved with. In every one of these cases, it was fixing a comfort complaint that a client had and then applying the knowledge to improve the construction of the home. Because I like to engineer stuff out of the home. I hate that phone call, right? It's so painful when, it's because it's never at, 9 o'clock in the morning on a Tuesday with lots of time and lots of staff available. It's always the worst possible time. And it makes you look so bad. So we've done most of these changes to engineer these problems out of the home. Ironically, it just happened these steps also help to improve the overall energy performance of the house. So, okay, so indoor air quality. You guys in the States, you've got this really cool program, Indoor Air Plus from the EPA. In 2019, back at the EBA conference in Denver, Gene Myers from Thrive gave me a tour of some of his homes. I was really thrilled to be able to attend an IAQ seminar at his one model. I think it was on the last day, and we were able to test some IAQ measurement devices. Now, for me, it was a real eye opener because I love cooking with natural gas, but having that IAQ monitor with the gas stove, it really showed me why it's a good idea. So up here in Canada, we don't have an indoor air quality program. We're trying to negotiate to bring Indoor Air Plus up to Canada. And I also, here's a shout out to you guys at EBA for being such a great source of information to help with indoor air quality programs. I really believe that Canada's got to get caught up and we need a program, even if it's at a pilot level, to do this work, because it's really a challenge when you have to beat the path in the snow by yourself, right? But here's a question I ask all my clients, and that is, when would you like fresh air? And it's incredible the number of people that used to say, well, in the summertime or at night, or, well, I like it when I'm sleeping, or I like it in the wintertime, right? And I'd coax them until I got them to what I consider to be the right answer, which is all the time. When would you like fresh air? All the time. And so then I am able to explain to them that we give them 2 sources of fresh air. We give them windows that open, and you're welcome to have them open whenever you want, but we know there's a lot of times they're going to be closed. And then the other one is a fresh air machine, right? But regardless of what answer they give me, it's important that we guide our customers to the right answer, which is fresh air all the time, and how we're helping them to have fresh air all the time. I consider that to be a key piece of what we do. Here's why fresh air matters. In the States, and I think Canada is fairly simple, I believe in the last 30 odd years, there's been 5 chemicals banned, right? In Europe, it's somewhere in the neighborhood of 1,300 chemicals that they've banned. So right now, as occupants of homes, we are exposed to more chemicals in 30 days than our grandparents were in a lifetime. And then we wonder why we have all these different autoimmune diseases and ailments, and kids with asthma and allergens and all of this stuff. We're poisoning ourselves and we don't even know it. It's just that constant drip of slow exposure that it's kind of like putting the frog in the pot and turning it on and letting the water come to the boil. And that's what's happening to us, folks. It's pretty critical. So there is some hope. One is, putting in a fresh air machine. Now, I'm not sure if everybody understands the difference between an HRV and an ERV, but HRVs are not ERVs. All ERVs are a form of HRV. HRV is a heat recovery ventilator, so it exchanges and recovers heat energy. An ERV does heat and moisture, so latent and sensible. Why I like ERVs, especially in my climate, is that and I was told for years, you can't use an ERV in a cold climate. And then I found the Van E that does in fact do that. We find there's less overdrying in winter, which was critically important to us. We actually had times where using an HRV, we would get the humidity down to like 10% levels, and we're trying to blast moisture into the home all along, right? And then also less overwetting in the summer, right? So we think that that's an important piece as well. I love having an ERV with an ECM motor though. It helps to provide additional ventilation capacity. Now we've moved up to the 90H, and part of that is because we are finding that there's more occupants in the home, and certainly there for a longer duration. So we have to give them fresh air over a longer period. And then we look at dedicated dehumidification.
Doug, can you just add for everybody what you're in Ashrae climate zone? Are you in 5?
Yeah, I think I'm in 5. Yeah. So I'm right around near Detroit, Michigan, and Cleveland, Ohio. I'm just a little bit north of that.
No, and I think
Detroit to Buffalo.
Yeah, and I think that's a key point that you say is that the old rationale would have been, oh no, climate zone 5 and above, you always have an HRV. And what you found over the years is the ERV has really been the answer for your builds.
Well, far better. In fact, one of the key reasons for that is because what we found is that we would have HVAC contractors that would be dealing with humidity complaints in the summertime. And they would say, well, turn your HRV off in the summer. Come again now? What? So you don't need to have fresh air in the summer. Okay, well, imagine we're putting your head with a big plastic bag over it and saying, okay, you're allowed to put a straw in there in the winter, but in the summertime, you can't have a straw anymore.
Yeah.
How does that make sense, right? And we found that all the time because it was dumping so much humidity into the home that was their answer. And so we found by switching this, I mean, you still need to deal with dehumidification in the summertime. Don't get me wrong. It's not a panacea, but it's a huge step in the right direction. It made a really big difference for us. And so when you're looking at a northern climate where you've got humidity loads and these homes, that's one thing about the net zero homes is they have really a higher humidity expectation in them. There's going to be more moisture because they're tighter, they're higher performance, right? So you have to deal with it. And we found that the ERV is just a much better way to go. But most of the clients I talk to them about, it's a fresh air machine that helps deal with moisture and heat, right? Gives you fresh air all the time, right? Oh, sorry, I was on this slide here. We are now starting to experiment with whole home dehumidification, though, and I can see at some point in the not too distant future where we probably will have to deal with that. Now, that doesn't get away from wintertime having to, possibly add moisture to the home, but cooking with pots with water, having plants, those are really great substitutes for wintertime. But what we're finding is, and it took me a while for our energy team to really start to come around to what I was saying, is that you've got the shoulder seasons, the spring and the fall. And what we're seeing here in our climate is that we are having higher humidity loading events in the spring and the fall, when traditionally you would have thought that you could pull fresh air from outside and use it for some dehumidification. That strategy doesn't seem to be working at all anymore. And it's been maybe 4 or 5 years where spring and fall now is really, it's not necessarily air and it's not necessarily rain that's happening. It's a higher humidity load in the air, relative humidity wise. And it took a while for the guys to believe me. I was talking with Andy Oding about this, and he's like, Doug, that can't be right. Like the math says. And I said, I'm telling you, this is what's happening. And then a couple of years ago, he came back and he says, you know what, we are starting to see this with some of the other high performance builders. And what's happening is you're getting this high laden moisture in the air. And even though there's a relative temperature differential, the humidity is really so high that it's still overloading the system in the spring and the fall. The problem is that the temperature versus the indoor temperature, you don't need to run the air conditioner. It'll maybe run intermittently. It might run a little bit at a time, but it doesn't run enough to really give you dehumidification in those timeframes. There's also summertime peak loads, about 6 weeks a year we get it, where I call it the soup, but we get so much humidity that the only way to do it is to have supplemental dehumidification. So currently our strategy is buy an Energy Star rated dehumidifier, put a hose to it, put it right to the drain pipe. Don't try and do the, oh, I'll remember to empty the bucket. That just doesn't work. Run it all the time. I say set it at 50% humidity for summertime. You should be good spring, fall, and summer, right? But yeah, it's something that's really changing, and it's part of our climate change issues that we're finding we have to deal with. Okay, so off-gassing and VOCs. This is another really interesting one. And again, EVA's got this really great program that you guys have just come out with that gets into this asthma and allergens concept. So I'm not going to tread too much on it because I don't want to repeat something that's fantastic. I would just say.
And for those viewing, it's the Healthier Homes Awareness for Building Professionals course that you can take on the EVA Academy.
Yeah. It's excellent. Really good stuff. But when you look at things like that new car smell, or those fresh air thingies you plug in air.
Oh yeah.
That's actually volatile organic compound off-gassing. It is unhealthy for you. You should never put those in your home. If your home stinks, figure out what's making it stink and get rid of it.
That's right.
Like the garbage, maybe, because the other. God bless the grandbaby, but he's still wearing a diaper, so, we're not that green. We still have to deal with that. But sometimes he lets one go, and it's like, you got to get that out of the house. Okay. You can put how many of those fresh airwick thingies in you want, and it's still going to stink. Right. But you're also poisoning yourself. So we want to be really careful about that. Unfortunately, some people think, well, zero VOCs must be bad. Like if zero can't be good, why shouldn't I have some? No, you really don't want any. Right. So on my path of exploring zero VOCs, we got into a company called Grafenstone, which is an EcoSmart paint and specialty coating company. It's based out of Spain. I was actually so impressed with their product that I negotiated the Canadian rights. Global marketing campaign is My Home is a Tree, and we're actually our first apartment buildings we're doing. It would be My Building is a Garden, because of using zero VOC paints that are actually absorbing CO2, which is really cool. 3 buckets of that paint is equivalent to an adult tree weighing about 250 kilograms for absorption for a year, it's pretty nice. But there's quite a few products. I only point this out because of personal interest, on self-gratifying plug here. It's to make us think about, there are different things that we should look at, and what we put into our home is actually very important. So it's also looking at art for your walls. So this is actually in one of our model homes. This monolithic concrete look is actually very popular, but again, it's actually absorbing carbon as it's curing over the first couple of years. And then we can also, I don't know if I can get to the feature wall slide here. It might not show it for me. Yeah, okay, so this is colored throughout, and it's in the foyer of a home that we did last year, and this is becoming really quite popular. It's also great when you've got that light flashing going across the wall of the home to be able to get rid of that complaint from customers as well. But that's part of looking at, can we reduce our indoor air quality issues by reducing our VOCs that are being brought into our homes. And when we look at traditional VOC measures, which they're under review now here in North America, you can have a zero VOC paint and it's still got formaldehyde and this other little nasty one called MI. So Michael Ignatius, MI. And these are preservatives. In fact, MI actually was used in makeup and things like that as well. But if you're allergic to it, so it's not a toxin, they're both allergens. If you're allergic to it, it can make you deathly sick. And so we want to make sure that we're looking at those types of products. And again, I'll point back to the Healthy Home program as being a really great resource to consider, right?
Doug, do you consider third-party certified, like Green Guard, Children in Schools level products, or do you use something like that as you're selecting carpets and paints and wall coverings?
We do. We're getting better at it. Again,
Yeah.
we don't have the benefit of having a really great program in Canada. So
Hmm.
a lot of what we've learned is by trial and error. But certainly I would, if you've got a program that can give you guidance in that. And again,
Yeah.
the Indoor Air Plus is a great start. It's
Right.
got reference ones. But yes, we do look at that. We're not perfect, Aaron. We're still on what I call the path of continual improvement on that one. But we're getting better at it and thinking
Great.
about it more all the time, for sure.
Great. Thank you.
Carpet one's kind of a tough one, but the certified hardwoods that are zero VOC are available, and we use quite a bit of that, which is great. We have an option for clients that say, I can't do the carpets. Well, here's what you can do, right?
Mm-hmm.
Climate resiliency should be on everybody's mind at this point. So we're going to look at climate resilient construction, but I'll also look at carbon reduction here for the next little bit, if that's okay. So I think it's fairly safe to acknowledge that our climate is changing. Weather is becoming more erratic, storms more frequent, more severe, and some regions are hotter, drier, and others are having more flooding. In fact, I think it was about 4 years ago that we had here in my area, in my town, we had within a 6-day span, a 100-year storm, a 250-year storm, and a 100-year storm in 6 days. So that's got to say something about the modeling of what's expected as a 100-year storm is now way off. And that's, it's happening with greater frequency. But then you don't have to take my word for it. In BC, and I know in the northern states, but it got up into BC in an area where air conditioning isn't even common, a heat dome. And this thing, we ended up with Lytton, BC, got to 37.9 Celsius. So that's like in the 90s, high 90s, right? And it basically, the town spontaneously combusted pretty much after multiple days of this and was gone, right? And what we found is in that 6-day period, looking at the reporting of deaths over that time attributed to the heat, they had in 6 days, just about half as many people die from the heat situation, from the heat dome, as from all of the COVID pandemic for the year and a half before that in BC. So there's around 1,700 people that died in the COVID pandemic in a year and a half in BC, and there was 800 people that died in 6 days. The emergency care system was just completely blown out of the water. It was very tragic. And so the concern that we have is what happens if something like that floats up in the Atlantic and gets over top of Greenland for a week? Then we're really in trouble. And the concern is that we are starting to see some changes happening to the North Atlantic current. So, that whole doom and gloom movie with Dennis Quaid in it, who knows, that's maybe not as science fiction-y as what we thought. But we do have to look at climate resilient construction, because in some manner, the climate has changed enough that we've got to consider resiliency as being one of our staples of construction. So a couple of key takeaways. Number one is don't build on a floodplain. And if you are, you might want to look at building on stilts. And my suggestion would be actually look at where the high water mark is at high tide, and then go 10 feet higher than that and go inland. And then wherever 10 feet higher than that high tide goes, I probably would be real careful about building there unless I've got a very serious climate resilient plan, because we're going to see more floods more often and more severe. Don't build in the tinderbox or adapt to non-combustible construction. Now, I'm not a huge expert on the Western fires, but there are guys that are experts. And certainly if you're in that area, you've really got to consider what you're building, and where you're building, because it's just, I don't think it's safe anymore. We've lost the battle on managing forests, really. And I don't see us getting that under control at any time in the near future. You just can't throw enough money at it to fix it. But we also need to look at designing and build for high wind events and high rain events. And it's not just anymore about, in the past, we always thought about keeping the roof on in the house by holding it up. Now we need to hold the roof down. And it's not just about rain coming down anymore. Now it's about rain coming up and in, especially on the leeward side of the rain event. So the storm's passing. And because of the severity, you're starting to see that the rain is whipping around and getting sucked back in the house on the leeward side. So it's really changing our dynamic of how we manage these events. Here's a map of tornadoes from Canada. You guys have probably got equal or better in the States, but the ones in red are F4s. Most of them are F3s. Very, very few of them are higher than an EF2. And even when you've got an EF3, really what you're talking about is a very narrow path that's at the EF3 level, and the broader band of destruction is done at EF2 or less. So we've been working with Western University for several years now. It started actually with our work down in Puerto Rico. We learned a lot about climate resilient construction, rebuilding roofs after Hurricane Maria down there. And what we did find here for tornado management is that it's usually EF2 or less, and that's common in the States and Canada. So if you can design your roof and construct it to hold it on an EF2 or less, you're going to solve 99% of the damage. Now, if you lose some shingles, that's okay, you put them back on. But when you start to lose the roof in general, then you're really going to have a problem. And so we started a pilot with the Institute for Catastrophic Loss Reduction to build a stronger roof. And as I said, typical roof construction is about holding the roof up, and they've put 3 toenails in to hold the truss in place until they get the sheathing on. And if you're lucky, the 3 toenails didn't crack the truss. With climate resilient construction, we're really talking about holding the roof down, like I said. And so we need something a little bit more robust, but we want to do it cost effectively and simply. So it's minor framing adjustments that we're looking at. There's really 3 of them, but a typical roof can be done much better for less than $1,000, right? So there's a couple of areas to look at. The first is the truss to wall connection. The second is what's called sheathing zones. And the third one is a gable end detail. So we're going to go through those really quickly. When you look at a hurricane clip, you're talking about 10 nails going in, and it takes about a minute using a nail gun to properly install one of these, right? We've been having a lot of success working with a screw from the Simpsons Strong Tie. I think MyTech has one as well, but it's about 8 seconds with the power screw gun, and you're looking at relatively the same cost between the hurricane clip and the screw, and relatively the same hold down. So, you know, besides the fact you want to hire framers that are around 6'5", which one do you think the framers would prefer to do? And that's where, you know, we got our costs down because we got our time down on our labor. It was just a whole lot faster to put these in as opposed to the hurricane clips. Now, it's not universal. There are some cases where the loading says that you've got to put in a hurricane strip clip, or even a double clip, depending on what you're putting in, but it makes a huge difference. And it's roughly around 650 pound of hold down. So real quick video here. Sounds a little quiet, but that's showing how quickly they go in, right? Now, the building inspectors actually really like this as well, because that screw is orange, so you can't fake it. And they're very easy for them to go and look and see, okay, I'm seeing the orange screw head. And so it's quite quick for them to do an inspection to make sure that it's actually there. Our framers don't mind it. Our site guys doing their site inspections are able to see it as well. So it's a great solution. You've taken the climate resiliency down from, you know, several hours down to, you know, about an hour per house, which is pretty cool. The next one is the zones.
And who is that, Doug? Who was that screw from? Is that a MyTech?
I think MyTech has one as well, but we're using the Simpson Strong Tie 6-inch hold down screw.
Okay, so instead of the hurricane strapping older system, you go to this new screw system.
Exactly.
Yeah, that's great advice. And then are you using the hurricane clips on the plywood roof as well, on their sheathing?
Yeah, up on the roof, the H clips to connect. Yeah. Yes. I'm actually going to look at sheathing right now. So,
oh, great.
You want to actually increase the length of your nail. We're currently using instead of a 2-inch, a 2¼ inch or 2.5 inch ring shank, or a 2¼ inch pass load. And there's 3 core zones on a roof. Okay. And so zone number 1 is the center core of the roof. And that's where the least amount of damage is ever going to happen. Zone 2 is your perimeter edges, so the overhangs, right? And so they need a little bit more attention. And then zone 3 is your bottom corners, and that's typically where you're going to run into problems. So a lot of that is because they'll put in little pieces of plywood sheathing, is basically they're scabbing it into the corner. And what you actually really need to do is take the opposite approach. And what you need to do is put in full pieces in the corners and along the perimeter. And then if you have to put like a partial sheet running through the center, then you put it there. Now the alternative is you can put a partial sheet at the very top if you block it in place. So there is a way of improving framing speed by putting the partial sheet up to the top, but you got to put blocking in to support it. So it's not just, in our mind, not just the clips, it's also supporting that partial sheet with a little bit of extra support, because it just doesn't have the overall structural load of nails. There's not enough nails in the truss to really hold it in place, right? So that's what we found as being really good. Now you guys have got a program in the States called the Fortified Home Program.
Yeah.
And we really relied on some of their detailing when we were working down in Puerto Rico. And we've done work with Western University and the Three Little Pigs lab research that they've done as part of how we've come up with this. So Dr. Greg Kopp and his team up here at Western have done a lot of work on this. And that's who we've been working with on this pilot project. The next one is where builders really tend to get in trouble. And I'll admit to being guilty that we used to do it this way as well, is the framers would scab on the gable end detailing, right?
Right.
And so you can see the scab there, it's just toenailed in. Well, that sheathing is connected to the rest of the roof in one of the weakest parts of the roof, right? And so what can happen is once that scab goes, there's enough uplift that it can zipper the roof at the gable end. And once you lose your gable end, you're losing your roof. So we really looked at this in detail and decided that that just wasn't quite the right approach. Lord knows I'd never want to walk on it, Aaron, because with my weight, I'd crush the thing and be falling off the roof, right? This one here would support me, which makes me feel a little bit more. They don't let me on the roof anymore. Don't get me wrong. In Puerto Rico, I got to cut wood, and that was about as much as they'd let me do. But no, you're not going on the roof. No way. So here we've got the gable end now has continuous framing back to the truss in the inside, and it's attached to the end wall. This is about 10 times stronger than that previous detailing. It's a little bit more time to do, but it's far stronger. So this is really where the variation in cost can happen on a roof. You know, it could be only $400 if all you're doing is adjusting your plywood a bit or your sheathing a bit and adding the screws. But if you've got to get into multiple gables, you can add a bit more money pretty quickly, right? And then because we like to share, here's a detail for folks done up by our engineering firm. It might not be accepted by your building officials down there. You might need to get it engineered, but it'll give you an idea of what to do. So it's looking at doing what we call an outrigger from the previous truss out over top of the wall assembly on the gable wall. And that's basically a scab to hold extra support on the piece that's going out to be on your gable front, right? And it is just significantly stronger because it's tying everything back in twice. It's not just a toenail onto the front fascia of the gable. It's actually connected to the gable roof and then connected to the truss behind, right? And then very importantly is that when it's connected to the truss behind, there is a nail that's on the underside going up into the underside of the truss to connect it and fasten it there. And that works really, really quite well from a loading performance standpoint. Oh boy, we're up onto another commercial break here. So
Great.
Poll questions. We're doing not too bad for time. We're almost through everything. But I guess the poll questions here is, are you having some of the problems, extreme climate events such as high wind and seeing any framing failures, flooding, forest fires, etc.? And I think I'm still seeing the original poll on there.
Yeah, just for the audience, if you scroll down to question number 4, you should be able to answer that question. We have a couple of folks that have pre-answered, and we're getting 33% on high wind events, 33% on rising insurance costs, although I assume that would be 100%. And then 67% on other. And if you could put in the chat section what your others might be.
Yeah. So here's why it's important, and this is actually why I'm very concerned about fire, is we, in my work with the insurance industry and with the home building industry at the national level, we're apprised of about what's called a reinsurer. So there's the insurance guys, and then there's these big multinationals. Some of them are from Europe, and they do the reinsure work on the insurance packages. And the concern is that they've come and said, look, Fort McMurray, which was a huge fire, it wiped out the town pretty much. That can't happen again. And our representative says, well, we hope it doesn't happen again. And we're hoping the climate, it's going to be okay. And the German gentleman says, no, that can't happen again. If it does, we can't afford to be here anymore. And we'll pull out of Canada, which would be the same for the States, right? That they can't make money, they're not going to be there. The concern is what happens to all of us if we can't afford to have homeowners insurance anymore. And it's really a deep concern of mine. It's one of those items that does keep me up at night about what happens if we can't get insurance for our homeowners, right? And so we do have to take climate resiliency very, very seriously, right? Anyway, keeping going here, the carbon question. So this is one that a lot of people have been starting to talk about in the last little while. So we're going to look at operational carbon and carbon reduction during construction here for a bit. And so I got to admit, I love wood. I love the smell of it. I love cooking with it. I love being in the forests. I love framing, just the smell of being on the job site. Carbon sequestration is a possibility with wood framing, which is really cool. And if we want to just get to the very basic root of carbon sequestration, it's if you have to dig it out of the ground and process it, it's going to add your carbon footprint. If it's something that grows and you process it and you store it in the building, then it's going to reduce your carbon footprint. So one makes it goes up and one makes it come down, and it's pretty much as simple as that if you want to get very, very simplistic about it. But it does come down to understanding the importance of material selection, and we have to stop looking at just operational carbon intensity. And that's where I think a lot of the codes are going and where the energy programs are fixated on. And that's maybe not where we need to be. We have to start looking at what's put in, because otherwise we run the risk of putting more carbon into the home than we can ever save by reducing our operational carbon footprint. So we look at what's called the total life cycle footprint, or decarbonization. It's a fairly new field. It's evolving. We're heavily involved. It's great to see that EBA is coming to the table to be a partner in this. But I really believe that net zero carbon has to replace net zero energy as the goal. And we've got to start wrapping our heads around why that's important and how to do it. So again, really simple. If you're looking at how to do this, it's biogenic materials to create a carbon sink or carbon storage. Now, Chris Magwood is going to be speaking at the conference. I don't know if he's going to be live or just doing a video call. Chris is one of the experts in there. We're working with him. He's at the Endeavour Center up in Peterborough, Ontario. Really cool guy, doing some really, really amazing research, but they're working on a carbon calculator, which I'm going to show briefly today. So you're looking at the carbon drawdown, which is the removal of atmospheric carbon. And then you've got carbon emissions, what's created by manufacture, transportation, that sort of thing. And then the difference between the two is the opportunity for carbon storage. So that's really what we're exploring now. And so here's the concern, is that if you don't deal with upfront embodied carbon, you can add more insulation that's got a higher carbon footprint to go to a net zero home, and you can actually increase your carbon footprint in the home. Here's an example. You go from 1.5 inches of rigid insulation to say 2 inches of rigid insulation. At 1.5 inches, you're getting away with a 9-inch concrete wall. At going to 2 inches, you're now up to a 10-inch concrete wall. See, because you're using a brick wall, right? So you've increased the amount of carbon in the insulation, and you've increased the amount of insulation in the carbon. You see, so you've got a double impact that's pushing that number up. So you could actually have a higher carbon number than you would from just doing a code built home if you're not careful about your selections. But there are opportunities here. And so Chris has created this sliding scale. And what we want to do is we want to get away from red. And what our company is doing right now is we're trying to ensure that we're down in the green or closing in on being in the green and getting the heck out of the red, right? So on deck 3, which is 2 weeks from now, we're going to come back and we're going to look at some research that we're doing as we finish up with looking at the selections we've made within the home. We're going to look at some carbon calculator information. So I think that'll be pretty cool for folks. So yeah, the first one, which is called the upfront embodied carbon emission. If you've got high carbon concrete and XPS and closed cell spray foam, now this is before they changed the blowing agent, so that number is going to come down now. Brick cladding, steel interior framing, drywall, vinyl windows. This is about as bad as you can possibly build from a carbon standpoint, right? And you're looking at about 241 kilograms per meter squared, right? Where we are right now as a company is we're probably slightly higher than the typical UEC, but we're trying to get into the teal range, if you will. And then our goal is within 24 months to try and get ourselves down into the conventional UEC. On the buildings we're building, though, we think our buildings might already be coming in on the best conventional UEC. We're doing a pretty good job on our buildings because it's all wood frame panelized construction, blown cellulose insulation in the walls. Blown cellulose is a great solution, by the way, because it's recycled content that was already grown once. And then you've got, Chris building his straw bale house type of thing is over on the far right. And that might be a bridge too far for production builder, but if we could get all production builders building into the yellow, that's a carbon sequestration situation, which would be pretty incredible. So our goal is to get somewhere between green and yellow within the next 24 months and then ultimately move into the yellow zone, right? And this is just a real quick snapshot at one section of the tool that's we're beta testing with Chris's team. And that's just looking at the foundation wall going from the highest conventional concrete 8-inch foundation wall down to using an isospan ICF. That's what he found to be the lowest, which was actually carbon storage that they were able to achieve. So I would say check out Chris's webinar if he's doing it by webinar, or if he's live, go see him. Really cool guy to talk to. So that's kind of what we've been working on, Aaron, is the 4 principles. And what we want to ask now is, are any stakeholders on the call seeing anybody asking about carbon reduction strategies?
Great. Nancy, if you could put the poll up. And if you go to number 5, that's the question we have. We have a couple pre-answers, which is municipalities and regulators at 33%, and then others at 67%. So I'd be interested if you can chat who your others are. That would be great. Clients 0%, and right now investors 0%. And I would guess, Doug, that's kind of a function of if you're a public builder or a private builder at this point.
Yeah. I think public builders that have investors in it that trade on the stock exchange are probably a lot more exposed to that than the smaller builders.
Absolutely.
We are seeing municipalities declaring climate emergencies all over the place. And unfortunately, sometimes the solutions they're coming up with might not be ones that we would consider the right answer. As an example, and Chris can tell you more about this, but the lowly plastic bag, the beating post of climate resilience in the marketplace has been replaced by all these canvas or cotton bags, and the carbon footprint of those bags is so big that you can probably make 1,000, or that's probably an exaggeration, 100 of the plastic bags for what you're getting out of the other ones. So we do have to be careful of the choices that we make, and oftentimes there's the rush to judgment, and I do blame codes on this, that thou shalt put more insulation in without really thinking about what insulation we're picking and why we should be careful about how we do it. So it's a little bit of a soapbox, but I am concerned that when we have municipalities starting to go off the rails and say, well, we're going to just make you do this net zero thing, and we're going to dictate to you how you do it, and they have no clue about what I just showed you here, it concerns me, because they can just accelerate the problem. And we as builders have spent a decade and a half trying to figure this out, and we've only in the last year have started even really talking about carbon reduction, right?
Right.
it's an emerging field for sure.
Well, I think that's one thing we've talked about, Doug, and with EBA is that if there's a province or municipality that is looking at a climate action plan, perhaps you want to get some of the best builders in North America involved to help you kind of critically think through that climate action plan, because we're seeing some decisions being made in a vacuum in some cases. So we at EBA would all like to be part of that conversation for sure.
Yeah, I don't know what to say about being at lunch. If you're not on the table, you're on the menu. Right?
That's right.
At the table, you're on the menu.
Hey, Doug, I was kind of interested, just one question on what's been your learning on concrete? Because concrete is an awful lot of the carbon footprint of our homes. And what's been your critical learning there? I'm sure you'll talk more about this in other modules, but.
We're just starting down the path of looking at increasing the slag or recycled content into the concrete.
Yeah.
Ash, as it were.
Fly ash.
So we're looking at that as being a possible solution as an interim step. I'm in very short time from now hiring a young lady. Well, we've hired her. She starts in a couple of weeks, and she is a building scientist, grant writer, and one of the things that she's going to be looking at, one of her portfolios will be the carbon reduction piece to be road testing products for us. And then, like always, I tend to, as I learn, we share it with the industry, right? And I know, Aaron, a lot of times guys will say, well, why would you share that with your competitors and that sort of thing? Well, if they want to get on board, that's great. I'm happy to share. I've always learned more by talking to others myself, but the concern is that we're running out of time.
Yeah.
So, we'll continue to share. I might not have all the answers in the next, 5 days or 2 weeks or before the conference, but we'll keep updating people as we go. But it's going to be on, the ash and possibly some slag content, depending, right? And then it could also be that we start to look at, okay, well, can we reduce the size of our walls? And there's a couple of ways to do that. One is maybe we got to look seriously at ICF because you're using less concrete there. And the other one is, if you go to siding, which isn't very popular in my area, versus brick, the siding, you can get away with a much thinner concrete wall, right?
Mm-hmm.
So you can knock an eighth of your concrete out just by making that one change, right?
Yeah.
So lots to consider. But anyway, for those that attended today, the takeaways are build your team carefully and build it early. Make sure you've got a water management plan and an air tightness plan and understand how to implement it. And we're going to get into that in the next section. Changing your paradigm, consider total value contributions. Stop thinking about cost only, because there's opportunities out there that you can actually both reduce costs, but provide better value to the customer. Like I talked about with comfort with the windows.
And what you're saying there in total value contribution, Doug, is that it's a systems approach to the house, right?
And we're going to look at the house's holistic system approach over the next 2 sessions. That's exactly what we're going to do. Right. Stop thinking about things in isolation, but how do they interconnect together? When you make one decision, how does it inform another decision? That sort of thing. It's not a perfect look at it, Aaron, but it's just getting people to think that there's a different way of approaching how we select items for the home and how we construct the homes, right? And that gives me back to what I call KICK, which is look at comfort, indoor air quality, carbon reduction, and climate resiliency. And if we can consider those 4 principles and then what I call the 2 fundamentals, you're going to build a home that can last 100 years, which is what we really should be looking at. Because code will get you to 45 or 50 years, and that's it, right? And then a big thank you to Eva for allowing me to do this presentation today. It was really, really appreciated, and looking forward to next week's. We're geared up and ready to rip, and hopefully we got some folks attending, but time for questions, I guess.
Fantastic. If anyone has questions, you can enter them in the Q&A section.
We talked a lot, Aaron. Holy smokes, we killed an hour and a half pretty quick.
Yeah, no, it's great. No, I think this is a great overview, Doug, and I'm really excited for the next 3 sessions and diving more into some detail. I don't see any additional questions coming up, so maybe with that we'll call it for today and look forward to seeing everybody next week.
Okay, excellent, outstanding. Aaron, are you able to stay on for just a minute?
Absolutely.
Beautiful, thank you. I'll stop sharing.
Thanks, everyone.